Hello, so this video is going to be on solving your trig ratios when they're in the different quadrants. So if you remember in class we talked about sine is going to be always y, cosine is x, and tangent is that slope of y over x. So in this first one, sine is going to be positive, cosine is also positive, which means tangent is going to be positive. For this one, our y is still positive, so sine is positive. Our x values would now be negative, so cosine's negative. And if we had tangent, well, we'd have positive divided by negative, so that's negative. We'll continue with the rest of the box. So if we were given that sine theta is negative 1/2, we would know that we're either, because sine is negative, we'd either be in quadrant 3 or 4. They also gave us that cosine of theta is going to be positive, then that means that we know we're now in quadrant 4. So we would solve for our other sides. So our if we had a triangle right here, we'd be saying, okay, here's our angle. This is 2, this is 1. We'll solve for this last side. And this last side, our adjacent side, would be root 3. So when we put this together, we'd say this is root 3 over 2. Our tangent is going to be that 1 over root 3. And when we rationalize that, that'd be root 3 over 3. Our cosecant is just going to be that reciprocal of sine, so negative 2. The secant is going to be the reciprocal of cosine, so we'll have 2 over root 3. Again, when we rationalize this, we'll have 2 root 3 over 3. And cotangent is going to be the reciprocal of tangent. So we'll have root 3. Now, because we're in, we said, quadrant 4, and we know that sine is negative, cosine's positive, that means tangent be negative.
Please pardon the interruption.
Sorry about that. And that means that cotangent will be negative. So if it helps to add your pluses and minuses at the very end, you could do that. If you want to try and add them earlier, that's okay too. So that is an example of a problem that you would see. If you have any questions on this, please reach out. Otherwise, have a good night and a good weekend, and we'll see you on Monday.